Okay, thank you everyone for joining our latest community call, the first one inside February. We have a pretty packed agenda today. The purpose of today's agenda is kind of outline to the work that's happening that we're going to do in a release of the Java SDK and the Dapr 0.4 runtime. And we're on track to kind of release these next week. And so we thought that we would use this opportunity to show beforehand the great work that we've been doing inside all of that, give you a chance to ask some questions ahead of it. And then as always, we'll try and cover these three demos. We're going to look at the Java SDK first. We'll look at the multiple state stores feature, and then how we've done MTLS or security level between the Dapr Sidecar instances to provide secure communication between the running instances of Dapr. So we'll do demos around each of those. I'll give you a quick update around where we are with the release, and then we'll kind of hopefully have about a good 20 minutes or so for anyone to ask questions. So with that, I'm going to hand it over to Artur and Leon to dive into what we're doing with our Java SDK. So take it away, guys.
Okay, hello. Can you guys hear me?
Yes.
Okay, and I assume you can see my screen as well.
Yes.
Hi, so this is like a documentation on our release from last week. So it's a beta version that works with Dapr 0.3. So today, if you're using Java, you had to use an auto-generated version of the gRPC client prior to this. Now, you can simply leverage Java classes to interact with Dapr. And it can be either with actors or without actors, okay? So these are all the features we support. It's basically everything today that is available in Dapr, all the features. You can use, of course, any IDE you prefer. We tested with Maven, but you also work with Gradle. And they have some examples as well that Leon gonna go through. So for you to use our SDK, you add these two repositories to your list of repositories in Maven, and you can add a dependency to our beta version today. If you want to use actors, you can add this dependency instead, okay? So we separate the features for actors and non-actors. Depends on your use case. To run examples, you can clone the repo, install it, and go through the examples yourself. And to debug any issues using a Java application, we have some instructions here on how to do the debug, okay? Now, this is what the version we released yesterday, on Friday, which is with Dapr 0.3. The latest version that we're working actively prior to our next release, which is going to happen next week, it's called a snapshot version. So if you want to have a snapshot version, you just make sure you use this version instead. This will work out of the master version that is in Dapr, not the latest release. So if there's any breaking change, this will not work with the latest release, only work with the master branch. And again, these are also instructions on how to use the same dependency using Gradle, if you're using Gradle, okay? So that's all I have. I'm gonna hand it over to Leon.
Hey everyone. So can you see my screen?
Yes, Leon.
Okay. So yeah, I'll be showing two small demos of the Java SDK. The first one is right here, which will be using bindings. So Dapr has bindings to support events. In this case, this is a small app that's using our Java SDK to do an output binding. That means it'll send a message into the component we've configured, which in this case is Kafka. Just kind of walk through this kind of fast. The name of the binding will be simply sample123. Here we're building a client. This is a client that knows how to talk to Dapr. And then in a loop, we send a message. In this case, a message is a string inside a user-defined object, the message field. And then here we call the SDK API to invoke the binding, which will send it off. And then to receive it, we have the example that's in the sample repo. I just changed the topic name to sample123, but it does the same thing where it will act as an input binding, that is receive message from the binding. So if I run the Node.js side right here, which is going to receive it, now it's ready. And now I'll run the Java app that'll be using the SDK right here. It'll come up and it'll send a message right here. And in a few seconds, it'll send another one. And you can see on the left side that it's getting received. Oh, and these can be, yeah, so in the examples in the repo, there is also an example of an input binding with a Java app, which I'm not going to demo here because we're using the Node one just to show different languages, but you could check that out later. So second thing I'm going to show is some actor functionality. Let's see. So with this demo, what's going to happen is that I believe last time Arthur showed actor method invocation. What I'm going to show here is actor timers. And so what we have here is when this actor, which is called demo actor, impl, is created, when it's activated rather, in its constructor, it'll register an actor timer with the Dapr runtime. And what this will do is for the period and duration you indicate, it will, which is 2 and 1, it will call into this actor the callback that you indicate. In this case, it's a method called clock, which we'll show below. And it also passes in the state that you indicate. Here we simply have a string called ping with a bang. Clock is over here. So you can see that it takes in the message that we indicate, which is ping, and we print out something. Similar functionality, which is not going to be shown here, but is in the repo, is reminders, which work similarly, but it's persisted. So let me show this sample here. On the left side, I'm starting the app that will host the actor. Now the app is ready. The actor won't come up until it's activated by a request from the actor proxy. So I'm going to start it on the right side. Yep, that happens. Let me try again. Okay. So what you see on the left side is that here it's activating, gets activated, so the actor is now up, and the clock method is saying ping, and it's showing the time on the left side. Now let me briefly show the client side, which is here. So this is a client side, which is on the right side of the window. Here we create a actor proxy builder, which will build the client. Here we build the client, and for the number of actors we have, we'll send messages. In the repo, the number of actors is higher. I changed it to 1 just for simplicity, for demo purposes. And we give it a random ID, and then we call method forever. In this case, what we're doing is calling 2 methods in a loop. One which is increment and get, and one which is say. These are just actor methods we didn't show. But what happens is that the actor doesn't get activated until we make the first call. And then after that, as was shown, the constructor will get called and a timer will get registered. And then that will get called every 2 seconds. So there will be 3 calls happening on the actor. These have a really long delay again for demo purposes, but if it was smaller, then you'd see 3 calls happening. One would be increment and get, one would be say, and one would be whatever the method is indicated by the timer method. The timer, which in this case is called clock, and these would all have turn-based concurrency, so they would not be called together. So those are the 2 demos.
Fantastic. Do we open up for any questions at all people want to ask? Or post anything in the chat window? If not, this is all our upcoming Java SDK. So if you want to go back and look at a video that Artur posted, the community call, the one before this last one, he also showed the Java SDK doing invoke functions, which we're pretty excited about the Java SDK. We're hoping that we now have 2 full-fledged SDKs. We have the Java SDK with client capabilities, along with actor runtime, and we also have the C# SDK. So we're starting to build these out, and we'd love you to try these out, give us feedback on them. We really want to hear, have we done this in the way that you'd expect a Java developer to enjoy the SDK and the API and what it would look like. So give some feedback. Okay, thanks, Leon. Let's move on next and go to the next demo.
Okay, I'll share my screen, Mark, for the multiple state store demo.
Okay.
Okay.
We can see your screen.
Okay. Let me share a different one. I shared my different screen, sorry. Okay. Can you guys see the screen now?
Yes.
Okay.
So just explain what this feature is as well first.
Okay. Are you seeing a VS Code window or a command shell?
VS Code window.
Okay, cool. Yeah. So I'm happy to share that with a 4.0 release of Dapr will have support for multiple state stores. Till 0.3 release of Dapr, you could not have multiple state stores for different applications running in a cluster. So till now, if you had multiple applications running in a cluster, you were only exposed a single state store. That means if you configure Redis for one application, only that would be available to each and every application running in the cluster with Dapr. But with this feature, you can configure multiple state stores with Dapr, and then each application can pick and choose whatever state store is right for its business needs. Not only that, with multiple state store feature, if an application wants to save states across 2 different state stores, that's possible too. This is a breaking change in the APIs. So the older APIs was like this. You call localhost on Dapr port, and then this was the URL. With the new breaking change, the URL takes the store name also. And this store name must match the store name as you provided in the components YAML for that state store component. So it's Redis store here. So if you want to talk to this Redis store state store, you would be appending this Redis store to the Dapr's state URL to perform state operations. So for this demo, I'm going to show you this small Python application saving state. So this is one of the routes for saving state. It's going to save a state in the Redis state store and the other one in the memcached state store. And then it has 2 methods to get the request. One is from getting the state from Redis, and the other one is getting the state from memcached. And it's going to use their respective URLs. This is the URL for getting the state from memcached, and that's for getting the state from Redis. So for this, I'm going to configure 2 state stores with Dapr. So this is the memcached store, and this is the Redis store, and it's getting its password from the Kubernetes secret store, which is the best practices you should use anyhow. And now I'm gonna deploy these applications in my Kubernetes cluster. So let me do this. And it's going to show you that Redis and Memcached is already running in my cluster. And then I'm going to deploy all these applications. So it's going to apply the components YAML for the state store, and it's going to create this Python application as well. Let's get that. So you see my Python application is running there. Let me get the logs from that application. So this is going to show the logs. You can see that Dapr has printed the logs that it has loaded memcached store, and then it has loaded the Redis store in it. And it's going to show the console messages from the Python application as it receives the messages. So let's do a port forward to this application so that we can make calls to it. Okay, so port forward is set now. So I'm going to make a call to save data method. This is going to call into this route configured with Python's Flask app, and it's going to save the state in Redis and then memcached. So let's run that call. It saved the state, and then you could see these messages being printed out from Python app here. Now let me query those messages back. First from Redis is going to return the state which I saved in Redis, which was a message, hello Redis. And then let me query the same information from memcached store. So this made the call to memcached and it returned the message which I saved in the memcached store. So that's the multi-state store feature, which enables you to not only configure different state stores with different applications, but configuring multiple state stores with one application. The scenario could be useful in case of one application. Let's say you want to have a in-memory state store with the hot cache, so you could save the information in that cache store, and then you want to have another persisted state store for storing your persisted information. So that way you can have two stores configured in your application. That's pretty much it from my side.
That's fantastic. In fact, that scenario is just what I was about to say. That's a great scenario where the cache is for your hot state store you're reading from, and then you're writing things out for more permanent state store, something like Cosmos or SQL or DynamoDB, in order to kind of you can do database queries over those sort of things.
Okay, I'll stop sharing then.
Excellent.
Mm-hmm.
Thank you. And any questions on that before we move on? Anyone want to ask about this? This is a pretty cool feature. It's been in our repos have been asked for quite a few months now, and so we wanted to get around to it because we felt that it was quite important for us to get this into your hands to play with. So any questions on that before we move on? Feel free to even open your mic or just post something in the chat window.
There is a question from Matt on the Java and .NET SDK. So Matt is asking if we have considered to support actors without requiring inheritance. So on the .NET side, from my understanding, there is a compatibility mode with the service fabric. But for the Java SDK, we do have plans to do actors by annotation only. We don't know exactly how, but we do have plans to support only annotation based.
So let me ask a clarifying question to Matt. Matt, is your question is regarding deriving from interface or deriving from the actor base class? Because if it's from the actor base class, we have to do that because it encapsulates lots of base functionality which is provided to the actor. But if it's regarding the interface, then what Artur said is correct. For Java, we are doing it annotations based. For .NET also, we can expose an annotation based thing if that's the requirement.
Master supply has been consideration for .NET Java primarily the active base class, but may be interested in using POJOs or POJOs.
Yeah, I think it's an option that we have to explore the possibility of it. will be interesting. But like Aman said, we have to see if it's possible because there is a lot of functionality provided by the base class.
Yeah. Okay. Yeah. Good question. Feel free, as always, to post an issue inside our repo. Okay, let's move on to our next demo. And Jeroen, you're up.
All right, thank you, Mark. I'll start sharing the screen. All right, can everyone see?
Yes.
All right. So today we're going to talk about automatic mutual TLS in Dapr, meaning securing Dapr to Dapr sidecars communication with mutual TLS and strong identities in Kubernetes. So first of all, let's see what that's going to look like. So for you as a developer using Dapr, or as an operator who's installing Dapr on top of their Kubernetes infrastructure, mutual TLS will be enabled by default. So if we go and we look at the charts, I'll close that here for a sec. So we're going into charts, Dapr, and then Dapr config. We can see that we have a default configuration now with MTLS settings. So it's enabled by default. I can also disable it from here. And the workload certTTL default value is 24 hours for the workload cert, and then some allowed clock skew to account for clock differences between pods. So I changed these for, to ridiculous values just to show you how we do cert rotation with zero downtime. So we're going to have our certificates rotating in the sidecars about every 15 seconds or so. So first thing I'm going to do is first create a Kubernetes namespace, because as you know, we've recently moved to Helm 3. So you need to create a namespace first. And now I'm just going to install the Helm chart. We're going to wait a couple of seconds till that finishes. All right, so it's been installed. And if we take a look at the pods, we can see that we have a new system pod for Dapr that was being added. It's called Sentry. And we can take a look at the logs for Sentry and start seeing what that means. So Sentry is basically the certificate authority for the Dapr sidecar. So we can see the configuration that it's based upon. We can see the port. We can see something called the CA store here, which is interesting because currently Dapr will issue self-signed certificates for root and issuer certs if the user hasn't provided any. We are going to let you provide also your own certificates. So you get a bring your own certificate type of scenario too. But the CA store, just like anything else in Dapr, is pretty pluggable. And so we'll be providing in the future the option to implement these as components, meaning you can have Let's Encrypt or AutoCert or any other certificate authority that you choose and trust to issue your certificates for you. And that's quite a departure, from other solutions that do that today. So here we can see the two configurations that we had. We can see that there is a file system watch. That's because if the root cert changes, the Dapr Sentry will actually load it without restarting it, without downtime. And we can see that it was loaded. We just generated the self-signed CA. Since we're running Kubernetes, this is now kept and persisted inside the Kubernetes secret store. And we're running, protecting y'all. Yeah. And here you can see the issuer cert expiry. So by default, it's 1 year. Okay, so the next thing we want to do is basically deploy the app, or an app, but one app would be kind of boring, right? So we're going to deploy the distributed calculator sample, and for those who don't know it, it's one of my favorite apps in the whole world because it has 5 different microservices just to do different operations on a calculator. So I'm just going to apply what's in here, and the pods are creating. So we'll wait, yeah, and I think most of them are done. All right, so now we have all the services running, and let's take the add app and log out the Dapr logs from that sidecar. So we can notice a few things here. First of all, we can see MTLS is enabled. We can see that these trust anchors, which is the trust chain, has been successfully extracted. And then we can see that the sidecar is actually generating a sign-in request, sending it to Sentry. It was signed successfully. And now it's actually starting a watcher for the in-memory stored certificate, and it will automatically renew it. So if we check the logs again, we can actually see that we've already rotated it several times. And Dapr by default will start rotating the cert when it reaches 70% of the lifetime. And it'll go to Sentry and basically do the expiration renewal all over again. So let's start port forwarding to the calculator app. And I'll go here and I'll do open HTTP localhost 5000. And this is the app. So now we have a calculator, and it's running with MTLS in the background. So all communications between the different services are protected. And we can see that we can basically just protect this really valuable information of calculator stats, because everyone knows that the most important thing to protect is 5 plus 5, which is 10. So yeah, about this app, every type of operation here basically sends off a message to a different microservice running in our cluster. And the nice thing is that all of our sidecars are currently being rotated, so their certificates are being rotated as we do these operations, which I could just pretty much go on, continue doing forever. And the reason why you don't see downtime is because we've built our resiliency into Dapr. So we now have retries for transient errors and cases where one sidecar tries to contact another sidecar, and that other sidecar currently has its certificate being renewed, and you get a transient error or on authentication. So Dapr knows how to account for that. And on the server side, we are now draining the connections gracefully. So all incoming connections into a Dapr sidecar will be gracefully drained, and then the calling Dapr sidecars will account for any error they might get and do exponential retries. So we're really striving for zero downtime here. Yeah, and those things will be parts of performance benchmarks that we'll do to actually verify and validate these things. And you know, new features without clarity and observability are not so good. And because it's a common theme in Dapr to basically make everything clear and visible to the user, we have also introduced a few changes to the Dapr CLI. So for example, I can now do, if I want to see if MTLS is installed in my cluster, I can do Dapr MTLS-K, and we can see that mutual TLS is enabled. So this is a really simple way to just check on the status of MTLS, besides looking into, you know, the logs of each and every sidecar. And if I were to do something insane like that, don't do what I'm doing here at home. This is highly unstable and not recommended. I am going to edit our configuration and just change it from enabled to disabled. So I'm gonna cut off all MTLS access in my cluster. Yeah, and then if I do Dapr MTLS again, so we can see that it's disabled. And something else that we've brought for the upcoming release of the Dapr CLI is Dapr configurations, -K for Kubernetes. And here you can see the default configuration that's installed in your cluster. So you can see the MTLS is disabled. You can view all of the different configurations that this specific configuration has. And if we're already on the subject, you can also do Dapr components. So we can see that we have state store with state.redis. That's pretty much it. We're also going to have a lot of documentation regarding how exactly MTLS works, how do strong identities in Kubernetes work. We sort of took the same approach as Linkerd, as our awesome friends from Linkerd have taken, to rely on Kubernetes service account tokens to basically verify a pod identity. Yeah, and that's pretty much it. So I'm going to stop sharing here and be open for questions.
Yeah, that's pretty good, Yaron. So there's nothing actually I have to do in my application at all then. It's just merely a configuration file that I set for Dapr itself, yes?
Correct. Now, yes, it will be enabled by default. There will be nothing special you need to do.
And then I just get secure communication with all my Dapr instances. And then if a Dapr, and then the renewal policy is on the, there's a renewal on the root cert as well as the certificate for each Dapr instance?
The renewal is on the workload certificate.
On the work, yes.
Yeah.
Good. So any questions on this? Great demo.
Yeah, thank you.
Marcin asks service account tokens or service account token volume projection.
Yeah, service account tokens. Yeah, service account tokens, and we're gonna actually move to time-bounded tokens when that feature hits Kubernetes.
And how does any of this fit in with any of the key stores like Key Vault or Google Key Store?
It doesn't.
Okay, just asking.
Yep.
Excellent. Does anyone got any more questions on that? That for us is a pretty important feature because now when you install Dapr, as Jeroen said, you get secure communication between all your Dapr instances. Security, diagnostics are sort of key tenets that we're pushing hard for. We did a lot about diagnostics a few months ago in one of our community calls. You'll see a lot more of that coming up. Those are sort of key tenets for us that we want to continue. So please continue to give us feedback on things that you'd like to see inside those areas. And security, as I say, is one of them that we're going to be pretty fanatical on. Great. So at this point, we've got about 25 minutes. There's a chance now for anyone to ask any question of your choice. It really doesn't matter what it is. Anything from roadmap discussions to things about an API to a particular PR to feature requests. I will repeat that for those who weren't at the beginning of the call, we're currently planning on releasing the Java. Well, we've released a new update to a Java SDK that currently works with the 0.3 runtime for Dapr, and then next week we're going to be releasing the 0.4 Dapr runtime that contains all those great features for the state stores and the MTLS work you've just seen, plus plenty of other features, smaller PRs and smaller fixes that we've got done. And we'll also update the Java SDK for that. So you'll probably see that on Thursday of next week. So that's a week this Thursday, so around the 13th of February. So we're pretty excited about that. And then after that, we'll be thinking about planning what we'll do for the next release of Dapr. So if you've got ideas or requests or particular features, just upvote them inside the repo on particular feature asks, and then we'll look through all of them and see where you want to go. I will also, as always, do a shout out for that. We're always looking for people, the customers who are wanting to take Dapr into production. So if you have a production workload that you want to build with Dapr, we're more than happy to spend direct time working with you directly to get that into production. So that's something that we're pretty keen on. We have a number of people we're really working with like that, and we're more than happy to bring you into that category and work closely with you. So with that, feel free to either open up your mic, ask questions that way, that's the easiest way, or if you want to post it inside the chat room, just do it that way, and we'll see what we've got. Monty asks, is there no limits on the number of, from Dapr on the number of state stores? And I think the answer to that, Aman, is?
There are no limits from Dapr's perspective.
Yeah. We continue to add state stores, by the way. Just this last week, if you saw us, we did work with a company called Lightbend, and they have a Cloud State as a state store, which is a replicated in-memory distributed state store. And we had a fun time building a new state store with them. So if you want to have an in-memory replicated state store, feel free to try that one out. Lauren says, love the MTLS work, well done. Yes, it is actually a phenomenal piece of work. We're pretty excited by that, just because security is truly important for us. Marcin says, really happy that you eventually use service account tokens. Don't understand the design with mounting root certs.
Yeah, so the root cert is to identify, just like in Linkerd and Istio, to identify the sidecar when it's talking to the CA itself. So we're sort of taking the Linkerd, whom we love, approach. So we're injecting the trust root via the sidecar container. I can send you a little bit of more info on that later. And we also have the proposal document, which basically outlines the entire architecture for the MTLS stuff. So you can go take a look at the proposal. I think it's issue number 777, if I'm not mistaken, just because it's a catchy number. So you can go take a look at that. And of course, when this is released in the 0.4 milestone, we'll have very explicit documentation. No problem with it.
Yeah, we're getting pretty fanatical about documentation. So if there's any docs that you feel that are ambiguous or you want more information on, please raise PRs against the doc repo. We're going to be doing a big update to all our docs next week. So yes, docs, code, docs. That's what it's our mantra, and security and diagnostics. So yes, please give us feedback on docs. We really want to make them as detailed and as informative as you want from a developer perspective. Other questions? I'm sure you got a lot on your mind. If not, we will cut the call short. But this is your opportunity to dive in with us.
Well, since no one else is going, do you guys at all, are you guys familiar with Rancher and the sort of enhancements to Kubernetes they support across multiple clouds?
Actually, for me explicitly, no. I haven't spent too much time. I know Rancher fairly well, but not about that feature.
Well, that's what it is. I mean, Rancher is a management system for Kubernetes plus all the other pieces, including their own Kubernetes distribution, to keep it uniform, whether you're using, Azure Container or Azure Container Service or what you call it, Azure Kubernetes, or the Google one, or that, where everything, it kind of flattens out the way all the unique things work to give you one method of doing everything. And it might be a good idea to at least keep an eye on how that's going to make sure you're compatible with that, because 99% of the biggest Kubernetes users use Rancher for the management and their related, projects, which are all open source, by the way.
Because of
hi,
that.
Dave. So I know Rancher pretty well, and I also talked to a few other guys at KubeCon. Yeah, that's definitely something to take into consideration. I mean, their federation training, we need to make sure that Dapr works in. Although I don't currently see a reason why it wouldn't work. There are also some pretty interesting integrations we could be doing in the future with some of their capabilities for federating separate clusters. So yeah, that's a good suggestion for us. Thanks.
Well, yeah, one of the main things would be to have a specially annotated Helm chart to make it compatible with their apps, which is just a little more annotations in the Helm chart, so that you actually have a GUI experience when setting up Dapr, instead of just specifying everything with -- set on the Helm chart, where it can generate, to make sure you haven't lost anything, and add yourself to their curated list of charts.
Yes, that's true. And we'll also want to do exactly that for OpenShift too, so that Dapr gets added as an OpenShift operator. And people will just be able to click deploy on Dapr from OpenShift.
Actually,
okay, I just wanted to make sure that was on your radar.
Well, even better, actually, could you just raise an issue against in the repo? That'd be great.
Sure.
Yeah, actually, that's good feedback.
And you also might want to consider doing some of the demos with it, just for the reason that it's easier to show stuff than going to a bunch of windows and a bunch of command lines and everything.
Well, funny you should say that. So we built a Dapr dashboard project, and
right, saw that.
And we're going to now start including that by default. So when it gets deployed as a container, so you can actually start doing some demos through the dashboard side of things, rather than doing.
No, I mean, even if you want to look at multiple containers, logs, things like that, it gives you all the tooling web-based to do all that stuff. So even for demo purposes, it makes it easier to get more stuff on the screen.
Yes. Okay, great feedback. Thank you. Yeah, we'll spend some time on that. Okay, there's a couple of questions in the chat window. Another small plug for interface-based stateless services, particularly valuable for dev communities and a broad spectrum of acumen. Yes, great feedback, Monty. All right, as 4.0 comes close, have you identified any primary features for 0.5? No, we haven't yet. We will be doing that next week. But as I just mentioned earlier, if there are particular things that you feel are important to you, go and find the issues inside our repo or raise issues and upload them. So please send us your ideas.
Yeah, from our side, we'll be focusing on diagnosability and observability so that it's easier to diagnose issues as they happen in production just by looking at the logs.
Yes. From Marcin, has any work on Service Fabric integration started? Which service discovery mechanism do you intend to use with Service Fabric? MDS or develop something new? No work has actually started on that yet. We factored it out so we can create a plugin for service discovery. And the service discovery would either go down to the naming service or probably layered on top of the reverse proxy inside Service Fabric that sits there, which is probably the easiest solution to do it on top of it. But there's a choice because Service Fabric has both the naming service and DNS layered on that, and then reverse proxy layered on top of that. So there's a bit of a choice around those things. But probably layering on top of the reverse proxy bit would be the easiest.
Yeah, so from Dapr side, we made service discovery a pluggable component. So when it runs on Service Fabric, it could use reverse proxy or DNS, as Mark mentioned. From Dapr side, it can, we have opened the doors for that integration.
But yeah, but it will be, we are getting there eventually. It's working with the Service Fabric team and their priorities and how we pull this together. But Service Fabric will be a target for Dapr. Ganesh asks, I'm new here, played with Orlean for some time, looking forward to build my POC projects with Dapr and hopefully provide some feedback in next call. Yes, please do. Awesome. We have now got your choice of first-class Java or in C#. And we'd love to hear your feedback about the next SDK you think is important. We're kind of considering Node or Python of those, but tell us what you think. Okay, well then at that point, if there's any other, it looks like there's no more new questions. We'll see you next on our next community call. Will be on the just looking up here. Will be on the 18th of February, so 2 weeks from now. For that, we'll probably have some update of what we're going to be doing in 0.5 to some degree. We might not have locked in it too much, but we'll always have a few demos to kind of kick everything off. As always, this post will be posted up on our YouTube channel, so you can view it there afterwards. And please just keep giving us feedback. We want to be extremely open with this. There's nothing preventing you from raising PRs or issues in the repo. And please just tell us any ideas that you have. And continue to drive to make sure Dapr is a great product that you can build these distributed microservices applications with. So thank you for your time and see you in 2 weeks' time.